So that's the probability of something happening. That's the probability of something not happening is just the opposite. So if I have a 30% chance of something happening, there's a 70% chance of it not happening because your value has to equal 1. And we like to be able to say, well, if they're either going to be, it's either going to be true or not true. So there has to be those things. That's the thing about probability. It either occurs or it doesn't. There's no in between. So, and they write it as not A. Okay. So A plus not A is equal to 1, or probability of not A is equal to 1 minus the probability of A. That's what this happens. So probability has to be one of those two things. There's nothing in the middle. There's no abstract. You're either male or you're female. There's no third choice. So that's the kind of thing. So you're either male or you're not male. You're either 25 to 30 or you're not. Those are your probabilities. That's what it has to look at. Okay, there's all kinds of other choices, but if you're in this group, then if you're not in the 25 to 30 year category, then you're in the other category, which is not that. So even though there may be other choices, your probabilities have to be 1. So you can either be either or. And it's called the complement because they add together and become a total package. Sometimes you see a bar. Sometimes you see a looks like an apostrophe. Sometimes you see a hooked angle, and I'll draw some of these out in class so you can see them. But there's different things that denote not A, and it just depends on the book. It just depends on who's writing it and which one they were taught. And so you'll see there's like 3 or 4 of them, but they all just mean that it's the probability of A not occurring. So a probability distribution says that we take our outcomes, we create the events, and we find the probability of those things occurring. So we take the probability of each individual outcome divided by the total number of outcomes. So the probability of HH is 1 out of 4, and the probability of HT is 1 out of 4, and the probability of tails heads is 1 out of 4, the probability of tails is 1 out of 4. So when you make a probability distribution, you're going to start with this. The probability of them, each thing should be the same. Then what we look at is we turn it into events to see, well, what is the probability of the events occurring? Okay? To make our probability distribution, we look to see, well, gee, there was only one place where we had heads, but there were 2 places that we had there's only one place where we had 2 heads, but there were 2 places where we had 1 head and 1 place where we had no heads. That created this. Here's our events: 2 heads, 0 tails, 25%, 0.25, 1 out of 4. 1 head and 1 tail happened 2 out of 4 times, or 50%, or 1/2, or 0.5. 0 out of 2 happened 1 out of 4 times, or 0.25, or 25%. Notice when they add up, they have to equal 1. If you didn't equal 1, you made a mistake, probably in rounding somewhere. So go back and check those things. If we make a histogram, here's what it looks like. So we've done that. Notice this is just another distribution. Remember we did it before when we had our histograms. We had all of our little pieces and we looked to see the probabilities of those things, and our cumulative distribution. Same stuff. It's all coming back in a circle. Alright. So here they just want to talk about odds, and so the odds of something happening, we look to see the odds of something not happening first. So if the odds of rolling a 6 on a 6-sided dice are, there's 5 out of 6 chances of not getting a 6 and 1 out of 6 chances of getting a 6, we multiply those and we find that the odds are 5 to 1. Okay, that's all that means. So odds are the chance of not getting something compared to something that it does, against the probability that it does occur. Whereas when you're gambling, they tell you how much you're going to win. So a horse race where you have 3 to 1 odds, That means if you pay $1, you're going to, and it wins, you're going to get $3 plus the dollar you originally paid. They always give that back to you. If you lose, you just lose the dollar. So that's what odds are. So if you ever hear odds there, don't get them confused. Okay. So a probability distribution just puts all the probabilities in. We find all our outcomes. Use a table. Use tree diagrams. Draw them out. Okay. Identify your outcomes for each individual event. So figure out what the events are. Get your totals and go. Okay, how many of each thing do I have? Because you're only looking for a certain thing. I'm looking for boys. I'm looking for heads. I'm looking for green eyes. I'm looking for whatever it might be. That make sure you find those pieces and how many times they occurred, so you have your events. And then you have a table where you add up you have all your fractions or decimals and make sure they add up to 1. So here they're going to give you another example. We're tossing 3 coins. We know that there's 8 possible outcomes because we've seen it before, but there's only 4 events. No heads, 1 head, 2 heads, and 3 heads. So only one of the outcomes has 0 heads. That's tails, 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 the last one. So the probability of that happening is 1 time out of the 8 possible outcomes. There are 3 outcomes that have 1 head and 2 tails. So the probability of that event occurring is 3 out of 8. The probability of getting 2 heads also occurs 3 times. So the probability of that event is 3 out of 8. We have heads, 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 tails, heads, tails, heads, and tails, heads, heads. So that occurred 3 times. And the probability of getting all 3 heads only occurred once. So that probability is 1 out of 8. And it looks like this. 1 out of 8, 3 out of 8, 3 out of 8, and 1 out of 8. We could have turned this into decimals. So I would have had 0.125, 0.375, 0.375, and 0.125. Or percentages, 12.5, 37.5, 37.5, 12.5. Make sure that you pick one, and depending on what the test or homework question asks, that's the one you go with. They're all, it doesn't matter, but they're going to ask you for a specific one. So unless they don't ask, then you have your free reign, but pick the easiest one to do for yourself. So if we have a distribution of, and here's another example where they're doing 2 dice, and they made all of their dice rolls. I made a table here where I can have roll 1 through 6 with the first die and 1 through 6 with the second die, and I add them up because I'm going to do that's what I'm going to do. I'm going to have my first die is 1, my second die is 1, I add those together, I get 2. My first die is 2, my second die is 1, I get 3, and so on, all the way through. And they highlighted the 8s because in the next slide they're going to ask, well, how many of them occurred 8 times? That's the only reason that's in blue. But they have all their values. What they're going to want to do is they're going to want to see, well, how many times did a 2 occur? How many times did a 3 occur? How many times did a 4 occur? How many times did a 5 occur? How many times did a 6 occur? How many times did a 7 occur? How many times did an 8, a 9, a 10, 11, a 12? We're going to find those events and put them in. And notice we have 6 by 6. We have 36 different possible outcomes. Okay? So since there are 36 possible outcomes and they found out how many times each one of them occurred, there was only 1 snake eyes, only 1 boxcars, 12 and 2. Snake eyes is 2, boxcars is 12. All right. And as we go through, we have 2 3s, 3 4s, 4 5s, 5 6s, 6 7s, 5 8s, 4 9s, 3 10s, 2 11s, and 1 12. And if I add it, I could turn them into decimals, but they'd be ugly, so that's why they left them as fractions. They left them as unreduced fractions just to make it easy for you to see them. Okay, this should really be 1 out of 18. This should be 1 out of 12. This should be 1 out of 9. This should be 1 out of 6. But they left them this way so you could see that they all add up. And if we add up these numbers, we get 36. So 36 out of 36 is 1. When we look at our graph, it looks like this. Oh, look, it kind of looks normally distributed. Our mean is in the middle. So which we knew should happen. So that's what that's going to look like. So those are how you make your distributions. That's what probability is, and I will see you in class.